college physics, OpenStack's college physics, working through some of the problems. Some I made up, some are from the book. This is number 14 from what chapter are we on? Chapter 25. Okay, so here's the gist of the problem. The gist of the problem says, hey, there's this retroreflector on the moon, and we can shoot a beam of light to the moon and have it come back. And then by measuring the time it takes, we can determine the distance to the moon. And actually, let me show you. I showed you this before, but this is what this device does. You turn it on, and then it measures, it sends out a beam of light and times how long it takes to come back, and it gives you a distance. It's kind of amazing that you can do that, and it measures very well. So, but imagine that I use it right here to measure the distance to the board, and I get, I got to push measure, and this is not going to give a good result. And I get 0.91 meters. That seems right. But now I pass it through this acrylic, and so it's going a little bit slower, and I measure, and I would get the same thing. But that's because I moved it. Okay. But if you were in place, you would get a different reading because the speed of light is slower in the glass, and so that's going to make it take longer and make it look like it's further away, even though it's not. So the problem is Earth, Moon. They are 3.8 times 10 to the 8th meters away. There is a 30-kilometer atmosphere for the Earth with an index of refraction of 1.000293. So what's the correction? And then I'm going to make this as, what's the difference in time whether you include the error or you don't include the error? So let's do the easy part. No error. No error. So in no error, I want to calculate the time. So the time it's going to take for that beam to go there and back. I can say the velocity, which is the speed of light, is going to be the change, let's say delta S over delta T. Okay, so how far did it go? Well, it went there and back. So that's going to be 2D over delta T. We'll call this delta T1. So D is the distance between those two. And it's technically from the surface. I don't know, but let's just not worry about that. So let's calculate delta T1, pretty easy. It's going to be equal to 2 times D over C. C is the speed of light. So it's going to be 2 times 3.84 times 10 to the 8th times 10 to the 8th. I feel constricted when I get too close over here. I feel like I'm running out of room, but I don't know why. It's just me, I guess. Divided by the speed of light, 3 times 10 to the 8th. Okay, let's put it in the calculator. Drop 2, enter 3.84 times 10 to the 8th, enter. I should have done that. 3 times 10 to the 8th divided by, and I get a time of 1.28 seconds. Okay, so let's put that over here. Delta T1, 1.28 seconds. Okay, now this second calculation is a little bit more complicated, right? Because I need to break it into two pieces. I need to first go through the air, and then I need to go the rest of the way. So I have that T. I need this D1, D2, let's call that. Oh, I call that T for thickness. Let's call that S for the thickness of the H. So D2 is going to be equal to the total distance D minus H. And that's going to make it complicated. Okay, so now if I calculate delta T2, I need to know the speed of the light. So index of refraction is C over V, so V is C over N. So I know the index of refraction, I know the speed of light, I can calculate the speed of the material. Now I can say the same thing, C over N, which is the distance, the velocity, is the distance traveled, which is going to be, let's break it into two parts. I need to go through this twice, I need to go through the rest twice. So the first part, let's calculate 2 times. Yeah. So this is going to be, and then I'll add the 2 times together. So the first time is going to be the distance through the atmosphere twice. So 2h over delta T A. That's the time through the atmosphere. And I can calculate that. Delta T A is going to be equal to 2h times n over c. Now for the other part, I have c over n is 2 times d minus h over delta t, what should I call that? M for the moon. I don't know what that's called. And if I solve for that, I get delta t moon. It's going to be 2 d minus h over c times n. So I can calculate those two times and then add them together. That's what I'm going to do. And then we can compare that to this time. Okay, so this is going to be equal to 2 times 30 kilometers, which is 30 times 10 to the third, times n, which is that 1.000293. I fit it in there. Okay, good job. Divided by 3 times 10 to the 8th. That's that time. Let's just get that as a number. This may not be the best way to do it, but you don't have to do it the best way. You can do it in a roundabout way. It's fine. 2 enter 30 times 10 to the 3 times 1.000293 times 3 times 10 to the 8th divided by. I get, let's just write this as 2.0 times 10 to the negative 4. Now for this other time, I get 2 times 3.84 times 10 to the 8th minus 3 times 10 to the 4th, right? 30 times 10 to the third is 3 times 10 to the 4th, times the index of refraction, 1.000293, divided by the speed of light, 3 times 10 to the 8th. Okay, let's do that. Did I do 2? I think I did. Okay. 2, enter, 3.84 times 10 to the 8th, enter, 3 times 10 to the 4th, minus times. So this is what's great about RP and calculators. You can do that. 1.000293 times 3 times 10 to the 8th divided by. And I get 2. I can't be right. Did I do this one, the other one wrong? Let's redo that very first one. Let me write this down. I got 2.56 seconds. Okay, so maybe I got this other one wrong. I had 2 times, so 2 enter 3.84. Yeah, I did that wrong. Okay, so the other one I can divide both the top and the bottom by 10 to the 8th, so I don't have to worry about that. 2 enter 3.84 times 3 divided by. Yeah, this is wrong. I'm left off the 2. 2.56 seconds. So if you were all the way over here and you're like, hey, he did that wrong, he did that wrong, he did that wrong. Well, you have to wait all the way to the end to see that I fixed my error. Maybe you fixed it. Maybe you stopped it and you went back and redid it. I apologize, but that's part of the learning process. I could redo the video, but I'm not gonna. I don't know why. Okay, so I did get that, and I have that. I can get the total time by adding those two together. Delta T2 is 2.5607. And so you see that we just have a 0.0007 seconds difference. And you could do that as a ratio. You could do it a bunch of different ways. And there's probably some algebra you could do here to make this a little bit more precise. But the idea is that light goes through the air slower, and so that's going to throw off your time a little bit. I don't think it was the best problem, but I wanted to do it because it looked kind of interesting. So there's that. I really don't deserve a thumbs up on that one. I don't think I did a great job, but it's done.